Good afternoon, boys and girls. In this lesson, lesson 6, we're going to solve by factoring. So to solve by factoring, the first thing we have to do is factor. So you want to make sure you're really skilled in factoring. So once we factor it, we're going to use something called the zero product rule to ensure to find the solutions. The zero product rule says this: if I multiply two things together, so if I'm multiplying A times B and I get 0, then that means either A was equal to 0 or B is equal to 0. So remember, when we're factoring, we are multiplying two expressions together, normally two binomials together, and then we're going to set each of those binomials equal to 0 to solve it. So the first thing we have to do, the zero product rule only works if the equation is set to 0. So that's going to be the first thing we do. We want to make sure that the equation is equal to 0, and I can find a highlighter. And then once that is equal to 0, we're going to factor the polynomial, and then we're going to set all of the factors equal to 0. Easy peasy? Well, let's try it. So we look at our very first case. We have x squared minus 25. So ignore the 0 for a second and just ask yourself, how do I factor x squared minus 25? So remember the steps that we go through. The first thing we ask, is there a GCF? No, there's not a GCF. How many terms are there? There are 2 terms, so we're going to try either the difference of 2 squares or the difference of 2 cubes. And we see that this is the difference of 2 squares. So we're going to factor that by doing x plus 5 times x plus x minus 5. So what that indicates is that either x plus 5 is equal to 0 or x minus 5 is equal to 0. So we're going to try both of those. We're going to say x plus 5 equals 0, and we're going to say x minus 5 equals 0. Just solving this one-step equation, I subtract 5, I get x is equal to negative 5. I add 5 to both sides here, I get x is equal to 5. So both of these are my solutions, so I write this in a solution set, negative 5, 5. Both of these are solutions. It's not order pair. It's just like when we did absolute value equations. Both of these answers are correct. Alrighty? Alright, so let's look at problem number 2. The first thing we want to do is, according to our list, we want to set the equation equal to 0. This equation is not equal to 0, so I'm going to have to subtract 12 from both sides. I want to put it in order, so I want to put in the order ax squared plus bx plus c equals 0. So that would mean that I would have x squared minus x minus 12 equal to 0. So then I ask my next question. I'm going to factor it. So when I factor my first question, is there a GCF? Is there a number that goes into both x squared, x, and 12? And there is not one. So then my next question is, how many terms do I have? And in this particular solution, in this particular problem, I have 3 terms. So I'm going to try to factor with trinomials. Since my leading coefficient is 1, I can simply say, what can I multiply to get negative 12 and add to get negative 1? So thinking about numbers that I can multiply to get 12 are 6 and 2, 3 and 4, 12 and 1. And the only one that would work would be 3 and 4 if I make 4 negative and 3 positive. So this becomes x minus 4, x plus 3. So then, once again, I'm going to set one set equal to 0. The other set I'm going to set equal to 0 as well. So I get x minus 4 equals 0 and x plus 3 equals 0. Solving that, I get x equals 4, subtract 3, x equals negative 3. So my solution set is 4, negative 3. Generally, I write the negative 3 first, but there's no absolute right or wrong way of doing that. Okay, so let's try the next one. Again, we want to start by setting the equation equal to 0. That's been done for us. Our next step is to factor that polynomial. We ask ourselves, is there a GCF? There is not. How many terms are there? There are 3 terms, so I'm going to use the AC method. So I'm going to multiply 3 times, because the leading coefficient is not 1, I'm going to multiply 3 times negative 21. That gives me negative 63. What two numbers can I multiply to get negative 63 and add to get 2? 7 and 9. I think that's it. 63 and 1. 21 and 3. But if I want to get 2 in the middle, this is going to be my best bet. And I want the 2 to be positive, so that means the 7 has to be negative. So this gives me 3x squared minus 7x plus 9x minus 21. I factor by grouping. I factor out an x, and I'm left with 3x minus 7. I factor out a 3. I'm left with x minus 7, 3x minus 7. Now we're cooking with beans, because I can do 3x minus 7. I pull that out, and I'm left with x plus 3 is equal to 0. So I'm going to solve for each of these. Now this becomes a two-step equation, so I have to be a little careful with this one. So 3x minus 7 equals 0. So I'm going to add 7 to both sides, and I get 3x is equal to 7. So x is equal to 7/3. For this one, it's just a one-step equation, and we get x is equal to negative 3. So my solutions are, I'm just going to write them up here, 7/3 and negative 3. Let's do a few more. For this one, again, it's already set equal to 0. I'm going to factor it. It has 3 terms. There's no GCF, and it has 3 terms. So what can I multiply to get negative 42 and add to get negative 1? So negative 42 is 2 and 21, 6 and 7, 42 and 1. So the only one that would work there is 6 and 7. Because I want it negative, the 7 has to be negative. So this is x minus 7, x plus 6, setting each of those equal to 0. I get x equals 7 and x equals negative 6. So my solution set is negative 6, 7. Okay, in this one, we want to factor out a GCF. And I forgot to write, that should say equal to 0. So excuse me for that. That should say equal to 0. So I want to factor out a GCF here. So the GCF is going to be 3x. And then I'll be left with x squared minus 4. So remember, I have to check to see if I can factor this again. And I can. This becomes x plus 2, because it's the difference of 2 squares. So now I set each of these. So this will have 3 answers. So when I divide by 3, I still get x is equal to 0. I subtract 2. X is equal to negative 2. And I add 2. X is equal to 2. So this has 3 solutions. And the solutions are negative 2, 0, and 2. I'll just put them in numerical order. And the last one, I think I made a mistake on that. I think I wanted to make that x squared, but it's just, we can still solve it. It's the same thing. X minus 4 equals 0. So we're going to add 4 to both sides. We get 8x is equal to 4. Divide by 8. X is equal to 1/2. We could have factored out a GCF from that as well. Okay. Pause the video. I want you to try these 6 problems on your own, and then come back and we'll talk about the answers. Okay, welcome back. In this first one, we had to first set it up so it's x squared plus 3x minus 4 equals 0. And then what we want to do is we want to factor that, so that's x plus 4, x minus 1. So then I get x is equal to negative 4, x is equal to 1. This is the difference of 2 squares, so that's going to be x plus 2. x minus 2, which ends up being x is equal to plus or minus 2. We can write it like that, or you can write x is equal to 2, x is equal to negative 2, however you feel comfortable. Most of the time I just write it like that. I keep forgetting my squares on these, so I'm going to factor out a 12, although it doesn't matter, and I get x minus 3. So the 12 is never going to make that 0, because 12 is a constant, so only thing I have to do is say x minus 3 equals 0, so x is equal to 3. And yes, you could have solved that without factoring. On this one, we get 3x squared plus 10x plus 3 equal to 0. So we're going to use the AC method because there's not a GCF and there are 3 terms. So I get 9. What can I multiply to get 9 and add to get 10? 9 and 1. So this is 3x squared plus 9x plus x plus 3. We factor out a 3x. We get x plus 3. We factor out a 1. X plus 3. So this is 3x plus 1, x plus 3. So that's going to make my answers negative 1/3 and negative 3. Again, for this one, I have to move 6 over. And then when I factor that, no, what am I doing? I don't know what I'm doing. I multiply a times c, I get negative 12x squared. So what can I multiply to get negative 12? Add to get 1, 3 and 4 again, and 4 is negative. So this is 2x squared plus 3x minus 4x minus 6. I factor out the GCF here, which is x. So I'm left with 2x plus 3. I factor out a negative 2 here because of the leading coefficient, and that's going to leave me with x plus 3, 2x plus 3. So then I have 2x plus 3, x minus 2 is equal to 0. So x is equal to 3/2 negative, and x is equal to 2. That leaves us with the last one. We have x squared minus 3x minus 18. There's no GCF. My leading coefficient is 1, so I can do the shortcut. What can I multiply to get negative 18 and add to get 3? 6 and 3. And that's going to equal to 0, so x is equal to 6, x is equal to negative 3. All right, that's it for solving by factoring, but I do want you to come back and we're going to check our answers to make sure that we've done this correctly. We're going to check that by using Desmos. So please watch the next video as I show you